Our skills with the Pico carry over to interesting other boards. Today I want to look at this small circular display which has an onboard RP2040 processor, the Waveshare RP2040 Touch LCD 1.28. This little display could be an ideal screen for a small project or a wearable device. The screen looks very similar to this touchscreen on my Samsung smartwatch. Hi, I'm John, your concierge to the world of the Raspberry Pi Pico, Pico 2, Robotics, IoT and other fun tech. Remember to subscribe and join the community. In this video, I'm going to review this Waveshare RP2040 Touch LCD 1.28 device. Like all my reviews, this is truly hands-on with the device and I've written my own code to test it out. So you will get a real feel for what this device is really like to work with. I purchased this device rather than it being given to me by Waveshare or a retailer, so you can be sure there is no bias in my review either. The bottom line up front is that I actually really like this device. It works well in my test. As is often the case, the libraries and demo documentation let it down a bit. If you like this video and it helps your learning or projects, why not drop me a cash tip using the super thanks button below the video. I'm saving these up to get myself to open source in San Francisco next year, and I'd appreciate your help in getting me there. I hope to see you there too. Please hit the like button and of course subscribe for more. So the RP2040 Touch LCD device is of course a RP2040 device. So it's very similar to our Picos. It's got a 240 by 240 pixel circular TFT screen with a touch interface and includes an IMU, so we are able to actually do gyro and accelerometer data on board. The unit's actually really quite small. It's 39mm by 26mm, so it's quite small compared with the Pico really, as you see them side by side there. It's USB-C though, unlike a Pico, which I like. The RP2040 Touch, in addition to the 2040 chip, it's got 4 megabytes of flash on board. So that's a little bit more than a Pico, which is ideal if you're storing images and graphical data that you're going to put onto that display. It's USB-C, as I've said, but and of course USB 1.1, like most other Pico devices. It's also got a lithium battery recharge and discharge circuitry on board, so you can use it basically as a watch or some sort of mobile device. And it has 6 GPIO pins available. Not a lot of GPIO are available in expansion on this. But there are 6 pins there and they are brought out via an SH10 header, and they've given you the cable with the unit as well. Those headers do not include SWD, so there is no single wire debug, and that caused me some problems working with this, because when my code crashes, and my code does crash, I'm honest, there is no way of working out what's gone on really. It's quite difficult to debug. This isn't ideal, and it's the one thing I really just don't like about this hardware. The TFT screen is a GC9801A driver. It's got the touch interface is using the CST 816S, and the IMU is a QMI 8658, and libraries for all of those are available and in the examples shipped by Waveshare. I could not produce these videos without sponsors. Today's video is sponsored by Kunkune, my favourite UK retailer for components. I love the ever-changing special offers of cool components. Kunkune has kindly offered a discount of 20% on the first order for you, excluding tools and test equipment. Just quote Dr Jon EA at checkout to get a 20% discount. So go check out Kunkune today. Waveshare do have a GitHub repo for this device with an example in it. And also there's a wiki page with lots of details about this product and getting started with it. And that also includes a second example using LVGL, which is a framework library to actually control user interface components like menus and buttons, etc. So there's some good examples there to work for. Let's have a quick look at those. So this is Waveshare's example, and it built for me without a problem. The code for the actual example is in the C in Examples folder. You've got a image data, which is basically just contains them massive image that they're going to bung onto the screen, and most of the other code is in here, which is doing all the setup and doing all of the drawing of various pieces on the screen. It's pretty reasonable and readable structure. It's using some libraries which are hard coded into this repo, and they're under here. Configuration one for the actual device, and then there are some standard libraries for fonts, GUI, which is sort of all the drawing, rectangles, circles, and text, etc. The LCD screen management itself, the QMI, so this is the IMI unit, this is the IMU unit, so this is what's giving you accelerometer and gyro, and the touch sensor. Libraries are fairly easy to use. They could be better documented, I must admit. There aren't much in the way of documentation in the code, but they are understandable, and I'll talk about my experience using them in a second. So this is Waveshare's LVGL example, and it's got that graphic on the top. Then we go to a screen there where we've got the accelerometer data and IMU data. So as I move that around, you can just about see that I'm getting some movement of those data. I haven't really checked that data to see how accurate it is or usable it is, but certainly it's displaying okay on these displays. And finally, we've got some touch interfaces there. So this is what LVGL really gives you, is the ability to actually put widget components on there and move them around and play. Now, I must admit, I think you need quite a small finger or a very carefully designed UI so that you can actually interact with those components. To check this all out, I've of course done my own experiments and my own versions with this, and I've got my repo that you can go and have a look at to see everything that I'm going to talk about. So this is the repo with my example code where I've actually tried to use this display, and all of my examples are in this examples folder. So let's start by having a little look at the Hello World example, which was the first one I did, which is just trying to write to that wonderful little screen there. And we're basically just using the LCD library and the GUI library to actually paint stuff on here. And all we're doing is initializing the display. We're going to clear it to blue. We're going to set it how much brightness I've got on it, because that's on a PWM on there. And then I'm just going to actually put some text on there, which is, I'm actually going to put some text on there, but I'm actually going to draw a few things. So I am going to draw a circle, or a couple of circles, a number and some text, and put all of that on. They're all fairly simple primitive draws. There isn't a great deal of primitives in this library though. So, you know, if you were going to build stuff with this, I think you'd end up inventing quite a lot of your own primitives. But the library seems to work and was relatively easy to copy their example and get that working. In fact, the main problem with getting this to work and being able to build this was the libraries themselves and the CMake structure in those libraries. So in my version of the libraries here, if we pick something like GUI, I've actually had to heavily rewrite their CMake list.txt file, because actually what they had in there didn't really fit my normal project structure and what I think is a normal project structure for a Pico project. So my version of these has got rather enhancements to the CMake structure to make it load properly as a CMake library sitting within a Pico context. So as I plug the power in here, we can see the screen will turn on and go nicely blue, and then we'll get my circles and a little bit of text just displayed on it. I've got a touch example as well where I've played with the touch library. That was fairly easy. It's this CST816S header file, and basically we can just initialize it, and I've initialized it into gesture mode there. It has gesture mode and point mode that you can set up, and then what we can basically just do is grab the point that was last touched on the device, and I'm just printing that out, and I can basically use that to see if I'm touching one circle or another on my display. It's not particularly exciting, and you've seen that the touch works because we had a look at Waveshare's own much more impressive demo. But I just wanted to check that I could get these stuff to work and understood how their touch interface works. One of the things that really attracted me to this device was the support for the LVGL library. So that gives you all of the primitives for actually building UIs and interacting with them. And that looked like quite a good accelerator for some of my projects. Now, prior to buying it, I'd really only sort of seen the demos and I hadn't really looked into it in any significant detail. It's only when I started playing with it and looking into it and trying to build my own that I noticed that there are a couple of caveats here. The Waveshare demos are based on LVG version 8.1. Current version is 9.1, so we're a little bit behind. In fact, there have been another 5 versions behind, really, so it is quite a long way behind, and that does cause you some issues when you're trying to look up how to do things online. And yes, of course, the more modern examples are all written on version 9.1 or 9.0, and there are quite a few things that have changed, so that makes life a little bit tricky. Could we move to 9.1? Probably. I haven't managed to, for a couple of other sort of caveat reasons. And one of them is that I spent a huge amount of time trying to work out why my examples didn't work at all. And the reason they didn't work at all is because I was trying to do standard I/O over USB to give me some telemetry of what's going on. And if you look very carefully at the Waveshare demos, you'll find that they actually have turned off standard I/O over USB because it clashes with the libraries and the way that they're using DMA, I think. So that took quite a lot of my time to try and work out what's going on here. The other pieces is actually the whole structure and how they use LVGL and set this up in the demo is not really done in a way that is very easy to reproduce for your own projects. So just let's have a look at my approach around that, which I think is a bit of a hack. The LVGL example I'm going to show you is LVGL project. I've taken quite a lot of time trying to play around with LVGL on this device because actually I want to use these for some projects. So I was keen to actually get a user interface that is touch-based and actually works. But this has been a little bit of a journey, and I've poured much more time into this than I would normally really want to do. What I ended up actually doing is basically bastardizing their example. So restructuring their example so it actually fits in a proper context of how I would want to build a Pico application, and trying to split out the really important bit for me to want to set up a UI, which is to be able to set up these widgets, which is basically just being able to run the widget init code. So here we have my widget init, and what I'm basically doing here is setting up some styles for my various components I'm going to put on the screen. Actually, I think there are more styles in there than I'm actually using, but you know, that's how code goes sometimes, and I haven't entirely sorted this out. Then we're going to put a tile onto the display, and the first tile is going to basically just have a whole set of arcs, which I'm going to actually rotate. So I'm actually setting up 5 arcs there, and then I've got a little animation utility, which is also part of the LVGL library, to actually rotate those. And finally, in the center of all of that, I'm going to set up a label and just put my company name in the middle there. And then I'll put a second tile up on there, and I'm going to put a button up on this one that actually I can push and see that I've pushed it. So that's all I'm doing. To compile this was relatively, well, to compile this took some work actually. First of all, I have moved away from their approach of using a local copy of the LVGL library, and actually instead I've got my a copy of the actual LVGL repo that actually being loaded as a submodule, and I've then backed that back to version 8.1 of the library, which is the version that actually works. I really would love this to get onto 9.1, but that's a bit of work that I haven't done at this point. The other caveat to be aware of with this, well, actually there are 2 caveats to be aware of. The first is the LCD library that they ship. There is a completely different version that they're using with LVGL. So I've actually got 2 versions of LCD library in this repo. One for the non-LVGL examples and one for the LVGL examples. There are some odd changes between the 2 that I can't quite say I understand. It looks like it's actually loading bit orders differently for LVGL, which is it kind of interesting, but I'm not quite sure I understand why. In fact, I don't understand why. So here's my demo with my arcs nicely rotating around my little label of my company name. And then as I push the screen up, we can go to a screen with a button on it, and I can just push that button. The nicest demo I've seen of using this is by a guy called Daniel Wienzek, and it's this sort of watch display where we've actually can use the touch interface to update the interface and change the time. He's got a nice little graphic behind there, and it actually moves around as you actually jog the screen using the IMU. It's a really nice little demo, which I'm not showing as well as I would love to, as I seem to be pointing mainly the lighting at you rather than actually showing the graphics. But if you've got one of these, have a play with his demo. It's really quite nice. It isn't using LVGL at all. He's actually hard-coded his entire UI on that, but it is very nice. And so what's my conclusion? Well, from a hardware point of view, I actually think these are really nice little displays and could be really useful. My one caveat into that is no SWD. From a development point of view, I could see myself getting really stuck, not being able to properly run a debugger against the code and seeing what's going on. Now, there is another one of these devices that has almost the same technology without the touchscreen, which does have SWD available to you. And I'm almost tempted to go and buy one of those, so at least I can get everything else working and then add touch in as a second step, just so there's a limited number of places where things can go wrong. The libraries are pretty good. They seem to all work and are functional. The slight difference between the 2 LCD libraries is a bit bizarre, needing a different library for the LVGL. The libraries do have poor documentation though. There is no descriptions around the methods, and I got caught with this, really trying to understand how to do some more advanced stuff with the IMU and see if I could actually get pan and tilt and be able to actually rotate the screen as I was rotating the device. and I couldn't work out quite how to do that. I'd have to take a lot more time and basically go back to reading the spec of the device itself and the chip itself, and then try and reverse engineer what the library is doing. That isn't really good enough, and I think I would expect better. The demo is also really leaves something to be desired, particularly the LVGL demo. The way that that is structured as a project and the way that the code is written there, you've even got an external variable called C, which they're calling, got between two separate C files. What is C meant to be doing? It's very difficult to understand, and that again I don't think is good enough. So I think there is more work that could have been done to make these devices easy to adopt for hobbyists and actually get going with. I'm fairly sure you will see these displays in some of my projects coming up real soon, so keep watching. If you'd like this video and it helps your learning or projects, why not drop me a cash tip using the super thanks button below the video. Remember, I'm saving these up to get myself to San Francisco and to the open source conference next year. I appreciate your help in getting me there, and I hope to see you there too. Thank you very much for watching. If you enjoyed the video, please hit that like button and please subscribe to my channel so you don't miss the next video. Bye bye for now.